In the meantime, before jumping to the presentation itself, I just want to, of course, welcome everyone and provide you an overview of this session. So it is, I mean, the name was pretty clear, satellite data for disaster management. So we try to have speakers from different stage of the disaster risk management phases. So from monitoring to forecasting to response in different sector of Earth observation. The session will include 7 speakers. So we divided in 3 each presentation will be of 15 minutes each. And we will have a first block of 3 presentations. Then a short break of 15 minutes where, of course, people can ask questions. For the attendee, you can put in the chat the question. In case you want to talk, I can give you the stage. And then we will have, after the break, another round of 4 sessions, again, 4 presentation, 15 minutes each. And then, of course, there will be opportunity to raise questions and having a discussion. I think, yeah, I think we can start. So the first presenter is Lorenzo Solari. Lorenzo is, Lorenzo, of course, jump in if I'm not correct. Lorenzo is a researcher at the University of Catalonia in Spain, but he is also currently working as consultant on SAR interferometry for the European Environment Agency. And I think what he's going to talk us today is about his work with the European Environment Agency. Lorenzo, I will give to you the role of presenter, and
Hey, thank you for the introduction. I think you can see the presentation, I suppose so.
Yes.
Okay, perfect. Yes, I'm Lorenzo Solari, and I'm not from the University of Catalonia, but it's a research center called the CTTC, so Centro Tecnològic i Telecomunicación de Catalunya. But it's true that I'm a consultant for the European Environment Agency, and today I will introduce you to in brief the European Ground Motion Service, which I see as a big opportunity to study geohazard at continental scale. So something that for disaster management, it's certainly important. And first of all, I want to say you that the EGMS is on its way to you. So we have started the production, and we will aim to deliver the product in March of 2022. And why it is now possible to have a European deformation map? Basically for 4 factors. First of all, thanks to Sentinel-1, we have now huge amount of data covering Europe, but also all around the world, with 6 days repeatability and a very regular acquisition plan dedicated to research. And then we have the high performance computers and the cloud environment, which guarantee us to be able to process this amount of data, this volume of data. And then we have the reliability of algorithm that has been used for 20 years nowadays. And so we are sure of the processing result. And then we built upon previous experiences and present experiences coming from some regions and some nations around Europe. The EGMS, it's fundamental to say that is based on user requirements. So it's a direct request of users, and the first stage of its implementation was back in 2016 when a task force made of several people coming from geological surveys and the interferometry industry prepared this white paper that paved the way to the implementation of the service that has been made via a call for tender, which was technical specification were based on this specification and implementation plan. The European Ground Motion Service will provide the continental scale homogeneous maps of ground motion, and the EGMS will deliver millimeter per year precision with full time series included. So the classic interferometric product with points showing a velocity value and time series. And the EGMS will map and measure ground motion and infrastructure displacement, including those caused by landslides, subsidence, and so on. It's worth to say that, of course, we have the classical technical limitation of the INSAR, for example, regarding the velocity over time, so we can detect only what is called very slow to slow ground motion. And the EGMS will provide a new European geospatial dataset from which other product and service can be made. This is fundamental, and I will explain later how the EEA will try to distribute as much as possible with users this new product. Key application areas, as said before, are mainly within natural risk mapping and asset management. So the classical landslide or subsidence mapping to check if a city is affected by a certain motion, but also depending on the scale of analysis, also to detect some motion related to the single infrastructure as the bridge you see in the image. And the ground motion service, of course, will enable uptake and downstream action for the benefit of end users and community. The type of analysis, it's what we can say today, the classical multi-temporal interferometry. So we will have to analyze this big volume of images. We can speak about 400 images on top of an area in Europe, and this stack of images will be analyzed to discover these coherent points where time series can be extracted. In urban areas, we speak mainly about persistent scatterers, so target which coincide with buildings or man-made structure in general. In peri-urban areas and in non-urban areas, we will speak about distributed scatterers. Of course, the starting point are Sentinel-1 images, which are going to be analyzed at full resolution. This is really important to say to imagine the amount of processing which is needed in terms of computational capacity. We're speaking about an input of petabytes of images to be analyzed. And then the EGMS will deliver three main products. The first one is the basic product. It's for people which that work with this kind of data. Is the classic deformation map with measures acquired along the line of sight of the sensor, and this is a relative product, because for every processing unit we are going to select a reference point which is supposed to be stable, and then we will calculate the velocities relatively to this point. So we will have 1,000 of processing points with 1,000 of reference points. The game changer of this service is the calibrated product. You will find also it called as level 2B product. Again, the velocities will be calculated along the line of sight of the sensor. But this time we will lose, let's say, the relative characteristic of this product, and we can say that this deformation map will be an absolute deformation map. Why? Because we are going to anchor the deformation map to a GNSS reference frame. So a velocity model that will be derived from a 50 kilometer, will be derived from the stations, the GNSS station available over Europe, coming from the UREF and the UREF densification network mainly, and then from the data of coming from this station, we will derive a gridded model, 50 kilometer grid of velocity over Europe. Then we will deliver a third level, which is derived from the calibrated layer, which is called the ortho product, which is a resampled version of level 2B. Why we need the resampling full resolution deformation map? Because we need to obtain data for each cell of this resampling grid, at least one data coming from the ascending and one coming from the descending orbit, in order to calculate the vertical and east-west displacement vector. So this is a resampled data, but a product which has not less information inside. It's a product that for me is specifically useful for interpretation. Then a bit of the time schedule of the work. As said at the beginning, we plan to have the baseline production ready for March 2022. Then we will have a check coming from the EA, and we will pass the demonstrational product to the pre-operational stage, where the product will be uploaded to the system and delivered to the user. And then we will have the validation of this product. In the meantime, we will start with the first annual update, and then we will have for this first framework contract 2 other updates arriving to quarter 4 of 2024. The EGMS will be, of course, made available for free and with no cost for everyone. So according to the Copernicus policies, we will have a Webgis where people can visualize the data and analyze the time series, for example. So click one point or multiple points and obtain the time series and extract the image of the time series from the system. Also, there will be the possibility to download the data through a dedicated portal, which this time will require registration, which again foresee no cost, but it will be important for the EA to track the users of the service. The Webgis will be accessible via the main Copernicus Land Monitoring Service website. A lot of documentation will be made available to the users, and this is part of user uptake activity. And what we are going to provide to users, a wide variety of documents. We will pass from very technical documents, so GNSS calibration report, the algorithm theoretical basis document, so very into the detail of the processing technique to a more simple document dedicated to a wide exploitation of the data. So, for example, the product user manual, where people will learn how to use properly the data and which are the limits and which are the pros and cons of this data. Another key part of the implementation of the EGMS is validation. Validation is clearly relevant for every INSAR product, but especially when we speak about the continental scale product. And the validation is based on the document validation of the EGMS product portfolio, which has been drafted by the EGMS advisory board, which is a group of 9 people coming from different European entities and countries, expert of INSAR. And the validation will use various methodologies and data types to certify that the quality of the EGMS product for each production run is within the user expectation, basically. User engagement is another critical part of the service, and we will plan user meeting, communication activities in general, training events, hackathons, and so on. And also there will be an help desk to help directly in the platform the user. I finished my presentation with a first look at the result. These results come from a test area which has been produced in the last month in order to be sure that the system is ready to produce this very important product. And these results come from France. This area has been affected over time by subsidence related to underground mining. And as you can see in the image to the left, these data are calibrated data. You can see some moving points, so the yellow to orange points where we can detect subsidence in the last 4 years. And this is the ortho product, so the resampled data that I highlight very well, which is the main component of motion coherently with subsidence. Then I show you a few examples of landslide, and as you can see, again, these are calibrated product. You see the difference in the sign and the color of the points. It's related, of course, to the fact that we have an along slope motion, and the vector is seen by different look angle depending on the orbit. And this is confirmed by the velocities that has a main east-west component as we expect from this kind of motion. Where to find some information, please have a look directly to the CLMS website. You can just click to the pan-European part of the website, and you will find the EGMS and a lot already of documentation that will explain what the EA and the production consortium are doing. And that's it from my side. Thank you for your attention.
Thanks, Lorenzo. I just want to remind the attendees, you can pose the question and I will then ask to the speakers. Of course, there will be opportunity in for 30 minutes time, eventually to have a discussion along with a 15 minutes break. I have a question, Lorenzo. 2 questions actually in the meantime. It's first, when will be fully operational the service, so when we will be able to, as end user, to access the portal, download the data? And second, if you think there is a specific group of stakeholders who can benefit the most from this, scientists, civil protection?
Yes, very clear. yeah, the product will be, when the product is pre-operational, then it will be uploaded in the platform and you will have access to the data. This means, let's say, 1st of April 2022 for the baseline. Then regarding the stakeholder, of course, as you know, the ideal target is the citizens. So ideally, we would like to arrive to the citizens, but the perfect target I see for the EGMS are clearly all the people involved in risk management, geohazard management, so civil protection, geological survey, and so on. But of course, the industry, for example, related to construction of new metro line, for example, or we can also see an impact of the insurance sector, because I've seen some use cases coming from Norway, where INSAR Norway is used by the insurance companies and also the reinsurance companies. Then, of course, we hope that there is some kind also of interconnection with other services as the Copernicus Emergency Service. To see, for example, we have an eruption. As we can see now in La Palma, we can check if in the past there was some kind of deformation already there. So I see the EGMS really as a background for many potential applications, and I hope so to see many relevant downstream actions coming from different groups.
Okay. Thanks, Lorenzo. And I will now move to Manuel Arias. So he's ocean physical modeling at Argans, which is a UK consultancy company which provide EU services mainly. Of course, Manuel, I hope I haven't done any mistake in presenting you and your company. I think you're going to talk about marine litter. We can assess them forecasting it with satellite data. And it's all.
Yes, thank you, Alessandro. No, you didn't do any mistake in the presentation, actually. I'm Manuel Arias, as Alessandro has said, and I represent the Argans Limited company based in United Kingdom. That we have a number of activities related to the monitoring and management of marine litter over the oceans, especially in the European coasts. My role in the company is Ocean Physical Modeler, Modeling Program Manager. So basically, I overview a number of projects related to ocean, in which part of it is precisely this component of marine litter. The presentation I'm going to do is actually related to the issue of marine litter. So this is a man-made risk for a number of economical activities and also for the environment, including tourism, navigation, and sea farming. In terms of the environment impact, there is concerns about marine litter as a cause of harm for marine life, which is especially problematic for some endangered species, and also for it can impact also the fisheries and introduce microplastics within the food chain that eventually can also impact human health. So marine litter has been bringing a lot of concerns in the last year, and Argans has been doing an effort along a number of institutes and organizations, including the Copernicus Marine Service and the European Space Agency, to deploy a number of services that could help to manage this particular environmental issue. and try to improve our capabilities to understand where are the sources and how the movement of marine litter through the oceans due to marine currents, it drives impact in different regions, different to the ones that are the original point of the contamination itself. So this figure, for instance, is just a map presented 4 years ago, in which it is highlighted where are the main known sources of marine litter, which are quite connected to the presence of rivers. So as rivers are the main input of marine litter into the oceans, and from there, marine currents and ocean dynamics transport the litter around the world, and quite often impacting areas that are different from the points of origin. So there is a challenge in trying to understand where are the real origin of the litter that it is found at sea, and how this litter behaves, not only in the point of view of the transport, but also in terms of what it is the expected residence time within the different marine domains. In this line, we have been working in 2 areas. One is to improve ocean modeling capabilities to help to forecast landing places for litter, so to provide a risk index that can be used by users, so that they can monitor and help to manage the expected impact that they could have in the particular area of interest according to the litter behavior. And also the detection itself of marine litter from space, because of one of the main issues from marine litter is the little amount of existing data and the difficulty that exists to detect and track marine litter in the sea surface by itself. So modeling is actually a supporting tool, whereas we bring remote sensing to try to improve real observations of this litter and ingest it eventually into the models to improve the capability of the models to inform properly to the users. Of course, in all of this, there is a number of limitations which I'm going to be mentioning today during the presentation. Just to go a bit further into this, basically marine litter follows the marine currents and tends to accumulate in particular areas. In this case, we are getting just an example from a recent publication within the Black Sea, one of the areas that we have been working also recently. And the maps in the left, they are showing essentially this behavior that compromises 2 components. One is concentrations in the sea surface, so finding areas at sea where these litters concentrations are higher than nominal, and also to identify what areas of the coast this litter is sending as a result of the ocean dynamics, wind draft, etc. Models can help in this component, but as I said before, remote sensing by satellite, it helps to actually identify where the litter is in a current specific moment, and also could help us eventually, once the methodology is improved, to even classify this litter and understand what type of composition it has, which is also one of the challenges that the community is interested in trying to address in the future. In the context of our activities, we have been working in the area of marine litter for more than 15 years. Most of it has been related to the ocean modeling component and transport, whereas in the last 4 years, we have put more emphasis in the use of satellite data, particularly Sentinel-2 and Sentinel-1, to try to improve the detection of floating litter in the sea surface as input for ocean models. In this sense, we have run a number of contracts with the European Space Agency, and the most recent ones, some of the results that we're going to show here are coming from them, are of 3 contracts that we have in the frame of the discovery campaign associated to the marine litter research that is being done by ISA-STEC. And from the Copernicus marine initiatives, in which we have one service actually operative for informing users about litter, which is called LitterTech. And the different 2 projects that we have in the area of modeling are the LitterTech that I have mentioned within Siemens and the Black Sea Project Service. and which basically exploit this part of the model that I have mentioned before. How can we improve our models for forecasting landings and trying to identify the most likely probabilities to have contamination by floating marine litter in coastal areas. And the service that it is pretty much common between the two is based in the forecasting of litter beaching using as initial sources the rivers. So what we do is to ingest into the model a litter coming from the rivers, and then we propagate this litter with the help of these dynamic algorithms. And the service has actually 4 components. One is the forecast of litter interaction in the ocean, so basically trying to estimate what is the input from the rivers. The second one is a forecast of the litter rates in the ocean, which, of course, this is done with the help of Lagrangian transport simulations. The third item, which is the forecast of the landing litter, which is one of the aspects more interesting for users, is to learn where this litter is likely to end. And a hindcast module in which, by knowing some initial positions of litter in the sea surface, we can roll back to try to identify the sources, which again is another element very important for the management of marine litter in the future. And in terms of the transport itself, the models are actually requiring a lot of information. Some of them are related here. So stocks currents derived from the wave fields associated to the given area, the impact of the wind dragging, which is correlated to the wind speed itself, the impact of the sea currents, and the combinations of all these 3 dynamical components bring us the drift speeds of the marine litter pieces in any particular direction. And this is used to compute the Lagrangian transport within a specific domain. And an example of this, for instance, is what we have in the Black Sea domains in the 2 images in here, and which allow us to track the trajectory of individual pieces of litter from the point of origin, or do the other way around, from a given position of litter, trying to find out the point of origin. So those 2 images are actual images from the current services that we have operating. And for the beaching, this is a bit more complex modeling because there is less known information about how the beaching process actually happens. So we have, however, done a parameterization based in the waves, the wind speed, and the sea surface height. And according to this, we can drive maps in which we take into account the geomorphology of the coastal areas, including bathymetry, to identify in what areas this litter is more likely to be stored after storms or after normal dynamics like tidal regions. And this example here in the right is one of the images of our litter test service within Siemens. And these white dots that appear on the coastline are the areas that the service is predicting litter is likely to get accumulated. And we have actually estimations of probability and concentrations that are shown here in the color bar. And the other aspect related to the services that we are providing is that for most users, daily information is rather important. So what we are generating in terms of products within the services, I have put the URLs there for people to access if they have interest in them, which include stranded and floating litter. So for the number of simulated pieces of litter in a given domain, we provide information about where they are in each interval of time. The drift speed, the stocks currents, wind speeds, and sea currents that we have been using the Lagrangian transport. The hindcast service, which allows the users to try to roll back, as I said, from known positions of litter to the potential sources. The group of litters by each of the rivers, so we try to provide some information according to particular rivers, because that is of more interest for local authorities. Draw migration of paths of litters per day, and detailed information about each of the litter pieces as possible. So actually the service provides a huge quantity of information to users, which is very nice for further data processing or specific or dedicated studies according to the needs. And in terms of the part of the modeling, as conclusions, basically, the modeling works quite well, but has some particular limitations. One, of course, is our lack of proper knowledge of the physical processes at the scales representative of milliliter. So most of the modeling that we are doing so far is based in macro scale dynamics that are well known and can be provided by other models, like, for example, GLORIS from Siemens, but GLORIS has a 7-kilometer spatial resolution. So for improving the data, we will really need much high spatial resolution models in terms of ocean dynamics than currently available. This is an area to work in the future, and that it is under constant improvement by ocean modelers. And other aspects that this is also very, very relevant is that the beaching itself, as I said, it is not really well known, and there is a good number of factors that can play a role in this beaching probability. And there is also a component of refloating, which essentially means pieces that have ended up in the coast that after another event, storms or tides, they can come back to the sea. And this is also an aspect that is not yet well known, so we have not yet included into the model themselves. Nevertheless, for providing proper risk estimations, we have still need to introduce some local specificities that must be addressed along the corresponding end users in the particular areas. In terms of the remote sensing, and this is something that we have been trying to work much more in the last years. As I said, one of the issues is that we are assuming the rivers are just the sources, but for an ideal modeling, we want to know where the real litter is at sea, and then try to identify what are the actual sources, so that this could be used for a better management of the risks themselves. And in this sense, we have run a number of projects, including Resmali and EO-Tracking for milliliter paid by ESA, the Black Sea tracking that I have also mentioned from ESA, and the Windows as proxy, which is still a running project in which we are also trying to improve the detections using satellite data. And all of those projects are focusing in trying to detect marine litter in coastal waters in as much as possible, and benefiting from the higher spatial resolution of Sentinel-2 and Sentinel-1. And this is just an example of what we are talking about, so our real detections of marine litter. So those are examples from Sentinel-2 images at 10 meters spatial resolution. And we have developed spectral algorithms that are able to identify this type of contamination in Sentinel-2 data. And the objective is, of course, to classify the information within the optical data, and eventually to introduce or match this information into ocean models to help to better forecast the litter, as well as to better understand and estimate what are the concentrations and masses of marine litter present in the coastal waters. The methodology, I'm not going to detail too much into this, but in a sense, we try to have an adaptive method which is able to take into account the specific characteristics of the coastal waters, because the characteristics of coastal waters is very variable according to the region. So we try to identify a robust method that is not so dependent on those characteristics. And for that, we operated in receiver operating characteristic rock curves that allow us to do adjustments of the spectral thresholds that we use for the various classifications of marine litter according to the specific characteristics of each of the images that we use. And ideally, what we aim to do in the future is to try to merge all this information from real detections and the ocean models, which we have already actually started. And this is an example of this. So this is from the Black Sea project I have been mentioning before. we operated with some model forecast using outputs from rivers with an artificial sea to get an idea of where the litter could end up. And then we process satellite data over those areas to see whether we could find confirmation of presence of litter. And in this case, we managed actually to find useful information in connection with satellite detections. This is for us is a good evidence that this type of tool actually could eventually work very well for the management of this environmental issue. And getting more towards the end of the presentation, one aspect also we have started to explore is to the introduction of artificial intelligence elements, so that to do detections of the potential sources themselves over land of these litter. So, as I have said in the introduction, most of the litter that we found at the ocean and coastal waters is actually coming from rivers. And the next question is how that litter ends up into the rivers. So one of the things that has been typically reported as one of the mechanisms in how this litter ends up, that is called mismanagement, which is usually associated to illegal dumping of trash and litter into the areas closer to rivers, or just bad planning of litter dumping sites in different countries. This is an example in which we try to use artificial intelligence to detect dumping areas, so that they could be taken into account into this full modeling exercise. So one day, what we aspire to have is a service that is able to try to map all these elements, so from the specific sources in the land until the very end point of litter into the oceans, so that to help to better understand this environmental risk, and also to provide useful information for the users and the management of this problem. And as final conclusions, the combination of remote sensing and drift model provides the better assessment of the probability of detecting plastics with the help of a priori information plus observations and environmental conditions. So we need the three elements, information about the three elements to do a proper forecasting modeling. The monitor of litter from the source to the ocean can be done using different tools, including the assessment of the risk of litter presence in the future. So what I said, forecast and hindcast are two good options when we are using this type of models. Individually, macro litter is too small to be detected. This is also something that is well known. And currently, we are working more in what we call litter patches, which is basically accumulations of floating litter in the surface. Having an homogeneous set of accumulated waste will never be the case. It is always a mix. That is also true. And it is also very rare to have huge accumulations, and we find more diffuse accumulations. Therefore, they are more difficult to see. So there is a huge challenge yet in the context of remote sensing. But the spectral signatures varies depending on the density and type of debris. So there is a hope for future better classifications of data, multispectral data or hyperspectral data. And waste locations in the water column is also one of the difficulties, as obviously water impacts a lot into the spectral information that we can get from satellites and limits the capability of using satellites for this purpose. And the main limitations that we are facing right now is the scarce ground truth or simulated data to really improve the methods. So with that, I conclude my presentation. I will be more than happy to answer any question.
Thanks, Manuel. Yeah, if everyone has some question, we have our own time, because it looks to me that probably some of the speakers will not be attending today. So the good side is, yeah, we can take more time for questions. I definitely have two, Manuel. Okay, because looks like people are quiet in the chat. So the first is about your model. Of course, it needs, you say, a lot of ancillary data like wind speed, sea currents. Are these data free, and are they easy to access? I'm thinking how, if you want to replicate this work in a data poor country, how easy could be.
Most of the data that we are using is actually coming from EGMS itself. So it's freely available and can be used for any other person that really wants to follow the same type of approaches. And the main limitation that we have in the data itself is getting realistic information at the scales that will be needed. So the difficulty we face, or the biggest challenge, was to downscale the existing data source, which quite often also comes from other models, to really have the spatial resolution that we needed for the services. But provided that this information is available, the services can be improved quickly in this line. We didn't find issues really to get access to any of the data, and as I said, it's fully available. Yeah, and mainly from Siemens.
The second question I have is, how far in time can go your forecasting at the moment? And also, the level of uncertainty. If you can stretch in time, how bad could be your prediction?
I mean, the issue of the hindcast, or I would say also from the forecast, is that the actual transport of litter is a non-linear problem, which we are somehow linearizing when we are trying to do the ocean model, so that there is a foreseeable solution. However, the more in time we depart from the original initial conditions, the less likely is to the predictions, whether in the hindcast or forecast mode, to be valid. Our estimation so far is that the results are reliable within 1 week of the data. So basically, when we do the hindcast or forecast, around 7 days is approximately the quantity that we have found still in a good degree of uncertainty to be useful. Longer periods like that, it's more complicated. Yeah.
And Manuel, we have also another question from Lorenzo. What kind of down-through data you need to test the results?
Well, real observations at sea and capability to do tracking of marine debris in the surface will be also a huge addition. And so far, we have been working in many of the developments with some teams that they are doing some field campaigns from time to time to identify the marine litters and how it is present in the sea surface. And this information is actually very, very useful for us to improve the modeling and the detection capabilities. But unfortunately, marine litter is, how to say this, is not a predictable event. So when you go to the field, there are no guarantee that you will see quantities of litter good enough to provide sufficient data, unless you are by chance in the exact areas or points where this litter could be more observable or visible. So for that, we are forced to use kind of climatologic data, in the sense that it's historical systems of databases from multiple campaigns. And ideally, we would like to have more in detail experiments, particularly for the dynamics. What I said, capability to find some patches of litter, which can be quite large areas, and then be able to monitor them for some period of time in order to see how they are behaving and how that connects with our models.
Thanks. And now I think I need to do a roll call, so I need to check if the next speaker is here. Is Priyank Thakkar. I don't think he's here. Please, do come forward. Text me, message me. Eventually, if he's not here, we can move. But I think they are not here as well. Thomas Chen and Derek Russo. I don't know if they are here, and I do apologize for it attending. Unfortunately, I'm not the only host here, so but I will take responsibility for this. And I think we can just move to Deodato. So Deodato Tapete and Andrew Eddy. So I will give you the both the role of presenter. Let me know if there is an issue. So Deodato Tapete, he works at the Italian Space Agency, and his main interests are, of course, application of Earth observation for land application, geohazard, and I think today will be about response activity, geohazard response activity. Andrew Ed is a consultant at Athena Global, sorry, and is essentially an international environmental risk management consultancy. I hope I didn't say anything wrong. I do apologize. We have time, so you can eventually fix any mistake I did. And I think Andrew is starting first, and Deodato is moving the slide. I think you should be both able now to handle it. I think both able to speak, and we can see your screen. So I will leave the stage to you. Thanks.
Thank you, Alessandro. Your microphone cut off when you were describing who I was, so I'll just trust that you did it well. Please go to the next slide, Deodato. So this is to present some experience we have within CEOS, the Committee on Earth Observation Satellites, and its working group on disasters. About a year ago now, we created a demonstrator called the Recovery Observatory Demonstrator. And the purpose of this demonstrator is really not to address the response phase, but to address the recovery phase. So I'm sure you're all familiar with the International Charter, with the Copernicus rapid mapping services, but there's very little in the way of support to ongoing use of satellite imagery during the recovery phase after the immediate response phase. And so CEOS, under the leadership of the French Space Agency and the World Bank, set up a project in order to allow the following of up to 6 major events over the course of the next 3 years, to be able to look at how satellite imagery can extract information that's useful to the recovery process. And this experience builds on a 4-year project in Haiti after Hurricane Matthew, where the Italian Space Agency, the French Space Agency, NASA, and a few others worked on similar things, but over a longer time frame. And most of what Deodato will present later is experience we gleaned through the pilot in terms of developing methodologies based on essentially SAR interferometry, but other sensors as well, to be able to extract information useful for the recovery. Why is this useful? Well, because during the recovery process, there are budgets put into place, reconstruction budgets, recovery frameworks, and up until now, the post-disaster needs assessment that fed these processes were based almost exclusively on field surveys. So the use of satellite data is actually a very critical element to be able to improve on these. And in a recent experience in Haiti, we'll be able to show how that was actually very useful, because we came up with very different results than the field results. So next slide, please. So the recovery demonstrator, as I mentioned, will cover up to 5 recovery observatories over the course of the next 3 years. And what we're looking at specifically is being able to influence the post-disaster needs assessments. These recovery observatories collect satellite data from a wide range of sources. And on a best efforts basis, participants provide input in terms of satellite-derived products. And these inputs are directly used by the World Bank, UNDP, the European Union in their post-disaster needs assessment process, and also in the establishment of recovery frameworks. Next slide, please. The team that set this up, I said, is jointly led by CNES and the World Bank, and I serve as secretary to that team. It also includes representation from the other members of the tripartite agreement, as well as UNOSAT, NASA, ESA, and the working group disasters ex officio. And case by case, as we activate, there are different space agencies that are called upon to contribute, and also value-added companies that contribute on a pro bono basis as an opportunity to show what they can do in these areas. And I certainly am available offline to receive inputs of interest from other companies that are interested in contributing to this. Next slide, please. So there have been 4 activations to date. Well, 3 really, one pilot, and then the test activation for the Beirut explosion. which is ongoing and provides every quarter an update on the situation of reconstruction in Beirut. The ETA IOTA activation, which closed just in September, and which provided information to 4 Central American countries following ETA IOTA hurricanes last year. And now, more recently, the earthquake in Haiti was the result of an activation, and that will close in early 2022. And there are a number of products that Deodato will present that we're working on in that regard. So I pass it over to you, Deodato. Go ahead.
Thank you, Andrew. Thank you, Alessandro, for the kind introduction. Do you hear me well? I hope so.
Yes,
Okay.
yes.
So basically, the second part of this presentation is focused on the lessons learned from the pilot. As Andrew said, the current 3 activations come out from a pathway that we have followed in the last 4 years during the CEOS Recovery Observatory pilot. At the end, we collected user feedback, stakeholder feedback, and also our own experience. I will show you in the next slides some of these. And just for summarizing the key points, I've put here the list just to point out that the arrow basically taught us that we need to coordinate satellite observations. You probably know that the CEOS has this concept of virtual constellation, basically using different Earth observation systems that, of course, operate differently according to different policies, different observation scenarios. They, on the other side, can coordinate to provide multiple satellite observations. And what we do in the CEOS working group on disasters is to meet the user needs and back again, coordinate the satellite observations to meet these requirements and specific requests. The second point, when you use different satellite observations collected with different technical parameters, basically you are called to implement a multi-scale and multi-temporal integration of the products that you can derive from these different satellite observations. And of course, again, this multi-scale, multi-temporal integration approach it needs to follow the different phases of the recovery observatory. And of course, if you think about any type of natural disaster, you have the aftermath and also the years after. So depending on the phase that you are looking at, of course, the type of value that the derived products can bring in is different. And of course, the type of activities that we can do to better analyze and translate in valuable information. Talking about information, it's clear that from satellites, we have an objective view of what's happening on the ground during the reconstruction and recovery phase. But this objective evidence is not enough. It needs to be contextualized, particularly because when we talk about natural disasters in a recovery and resilience building framework, typically this happens not only in our own countries, but also in countries that are characterized by different environmental settings, different anthropological contexts. And I will show you some interesting examples that we were able to capture during the DRO. And of course, this brings in another point, the validation and ground truth collection, because of course, to increase and favor the user uptake of our technologies and enabling them basically to input this information, these maps into their own decision process. We need, of course, also to make sure that this information is validated. And this is also not only a way to ascertain the accuracy and reliability of the products, but is also a very good way for the technological transfer to teach the local value adders and stakeholders how to use our own maps and derived data. In this, Earth observation exploitation platforms, such as those made available by ESA, and I will talk about the JEP, could be a potential sustainable mean, especially for stakeholders, to follow on from these experiences and being able themselves to use this data and generate products. But of course, we need IT facilities and of course training, and this is part of a wider aspect involving the recovery observatory activities, of course capacity building, creating a real capacity. So when I talk about coordination of satellite SAR observations compared to the priority areas defined by our user, that's exactly what I mean. Basically, during the RO pilot, the users, the local champions, the stakeholders told us the scale and the detail to achieve with the different satellite constellations operating at the same time. So while Sentinel-1, of course, was used for regional coverage, we upgraded this observation capability with TerraSRX strip map in both ascending and descending geometry, and a further upgrade in spatial resolution and temporal revisit was achieved with Cosmos SkyMed spotlight imaging mode at 1 meter spatial resolution. And all these data were made available also through the JEP as a mean to favor the dissemination of this data. So more widely, not only restricted to the operation team, but also to the stakeholders. So what we can achieve when we use this different type of data, for example, TerraSRX, during the very first phase of the recovery observatory, the event has already occurred. In the aftermath, we have, of course, the main surface changes related to the event. So, for example, during an hurricane, Haiti experienced severe flooding. This area in Tripoli, fortunately, was an area not particularly populated as many others that have been affected by the hurricane. But as you can see from these change detection maps, using the strip map images provided by DLR during the activation, it took nearly 1 year for a full recovery of the local environment to evacuate all the waters, meaning that this area that mostly is used for pasture rather than to rural areas basically was not available anymore to local residents for longer periods. And this is something that you can do in the very first period of the recovery observatory. What happens in the years after, because recovery is not something that happens in the immediate aftermath of the event. We are used, as Andrew said at the very beginning, we are very used to emergency response. Lot of attention at the very beginning after a disaster happened, but what happens really in the years after, when the local society, the local population needs to recover really during the reconstruction. And using the same TerraSRX data, in this case, in the years after, starting from the first year, we captured the first changes in urban areas related to the proper recovery, as well as those changes related, in this case, to coastal areas that were severely transformed by the violence of the hurricane and the storm surge. Upgrading these with spatial resolution up to 1 meter with Cosmos SkyMed spotlight imaging mode, in the years after 2017-2019, we were able to capture the urbanization. This has been done also with Pleiad images by CNES and CERTIT, and in parallel, it has been done also with Cosmos SkyMed data. You have to consider that this area is frequently clouded, so the advantage of having the opportunity to collect SAR data is of course advantages. And as you can see on the right, just an example, in a couple of years you see transformations not only related to the reconstruction and rebuilding of dwellings and houses and barracks, but also the creation of new roads. And this area is pretty hilly, so when you create this new infrastructure, you may also trigger some cascading hazards like slope instability. And of course, we are in an environment which is not only urbanized, but also quite natural. We have a river, the Grandance River. Of course, we monitored over the following 3 years what happened to the local ecosystem and the coastal areas. And interestingly, we captured some surface changes that we could not explain just using our own rationale of monitoring a recovering area, like, for example, in Europe. And I can show you some examples of what I'm referring to when I talk about contextual interpretation. Of course, during reconstruction, local population needs to procure themselves some raw materials for building construction, and that's exactly what happened in the following 3 years after the Hurricane Matthew occurred. So local population used basically local quarries very close to the Grandance River estuary. Delta, and also they used the gravels accumulated on the split of the coast. But as you can see, while the classifier, which was pretty accurate to document the presence of an anthropogenic area related to the quarrying activity, it was also accurate to observe the increase of bare soil. But in this case, bare soil is not only raw material, but is unfortunately also waste material, because you have to consider that hurricanes also mobilize a lot of materials that comes back to the coast once the event is finished, completed. And also because there's a river, you have a mobilization again from the inland towards the coast. So there's also a problem of waste management. And also this was pretty clear when we looked at the surface change maps and derived the classification maps documenting anthropogenic activities that were not due to urbanization itself in terms of new buildings, new dwellings, but rather accumulation of wasteland, open wasteland. Of course, adding on top of a very challenging recovery process, the issue of managing wastes and of course problems and issues on local public health. So you see, for example, in this case, the classification maps were obtained using Markovian multi-temporal region-based modeling, combining SAR data from Cosmos Skymed and Pleiad data from the multispectral point of view. Very accurate, but of course, if you do not interpret these signals accounting for the context, you would expect these as signals of new urbanization along the river, maybe referring to an increase of potential elements at risk. I don't know if you see my slides. Yes, okay.
Yeah.
So that's what I mean when you have to interpret the derived maps with local information. I moved to validation of scientific products because during this RO experience, we did technical missions involving CNIGS, basically the National Center in Haiti for Geospatial Information. So the local champion capable of embedding all these technologies from space together with their own capabilities of generating geospatial information. In this case, I show you some results obtained using multi-interferometric analysis using Sentinel-1 in both ascending and descending mode, using the GEP, the Geohazard Exploitation Platform made available by ESA as part of this RO experience. And during the validation, we basically transferred the typical way in Europe we use this data to validate compared to local natural hazards, in this case rock toppling, lateral spreading, and also areas that are of course at risk in normal days, but also during an hurricane event. You have to consider that hurricanes mobilize also strong winds, and also can trigger further rock topples and sliding, affecting possible elements at risk, such as near in the Jeremy Airport area. And the technological transfer basically is effectively done if you interact directly with stakeholders and user workshops. This has been done with CNES during the technical mission with the support of CNIGS and all the stakeholders, both organizational and international, involved in Haiti to favor this technological transfer. Andrew mentioned them at the very beginning of the presentation. So we held some very interesting workshops directly with civil protection in Haiti and all the stakeholders. And also we did some training at university, because it's the new generation that should take these technologies on board in their own professional experience and capabilities, and become the future champions in the local national system to use these technologies in support of recovery and reconstruction phases. So that's exactly the vision for the long-term objective of a recovery observatory. So following what happens after a major disaster has happened, creating a capability, and not only limiting ourselves in the emergency response, but rather creating capabilities for them to recover and be ready for possible new disaster, but hopefully with an improved capability and resilience also to better plan for future. That's also the concept of a road demonstration. Andrew mentioned specifically what a demonstration differs from the pilot in terms of, particularly with time scale. I just mentioned here the current SAR activities involving the use of SAR, for example, in the Arrow Iota demo. It's an activity currently done with Sentinel-1 in both ascending and descending geometry, involving directly EGMS, our commercial branch, involved in generating insert displacement maps that will be used to assess the condition of the local infrastructure and how they could be impacted by the natural event that has been the subject of the activation. I can show you now a couple of results. They are preliminary because they are currently being interpreted during the activation. So you see the ascending and descending geometry, making the best out of the archive information that we have. Another lesson learned during the Arrow pilot was that having long time series in the archive provides us with baseline information that can be used to assess directly and quantify the impact of the event. With regard to Haiti, the current demo after the earthquake occurred in August, the current SAR activities, and more widely the activities using satellite data, are with regard to the first phase of the PNDA, so the assessment and qualification of the areas where landslides have occurred, because you have to think about that this earthquake happened along a major fault. Nearly east-west, you see this pretty clearly in this map produced by BGC, a Canadian company, but also in the concentration of landslides that have been detected also by our partners from NASA. And as you can see, basically landslides are interestingly located in those areas along the fault and where the earthquake severely hit the country. And also not to forget that during this activation, also Copernicus Emergency Management Service has been activated, the international charter, as Andrew mentioned. And as part of these activities, of course, we are benefiting of these results that are prepared during the first phase of the assessment, but also we are investigating how to continue the experience of the Arrow pilot revisiting the areas that have been affected by Hurricane Matthew, now impacted by the earthquake and the Grace storm that followed soon after the earthquake. The current activities is to revisit with Cosmos SkyMed, Sentinel-1 and TerraSAR-X with the same multi-scale and multi-temporal approach, those 3 areas, and also perform a change detection analysis to see how these last events have impacted the local environment that was still recovering from the 2016 event, and of course continue the technological transfer and capacity building with local Asian partners. And with this, I thank you for your attention, and I'm available to answer any question. Thank you.
Thanks, Dato. Thanks, Andrew. And yeah, if someone from the chat wants to raise question, just feel free to exit. I have 2. It's from your experience, do you think that there could be, let's say, the risk that of course, having everyone possibility to access this data, everyone will, let's say, do their own interpretation without being an Earth observation specialist, and situation can go out of control in terms of false alarm or essentially any conclusion without any scientific evidence behind, just because now data is so easy, satellite data, to access.
That is something that we have already observed during other events that happened. For example, I'm thinking about the Kilauea eruption a few years ago and the appearance on the web of several of these maps generated by these open data, or anyway data that can be accessed through different sources. So that's of course something that we account. Just to be clear, in the context of DRO, the data are distributed through the platform, the JEP, to the operation team and the stakeholders. So that's of course in this way a monitoring of who's accessing this data. Of course, talking about Sentinel data, that's another story, but that's the question in my perspective when I talk about capacity building, creating a culture of how to use this data, and also how to use them very critically, because they have a lot of potentialities that to be honest are not anymore potentialities, are very known and consolidated capabilities to provide valuable information is the way how they are used. That's also the other aspect, the contextual information. Sometimes we witness some publication in the web of this data out of the context, and as you can see, I've just showed a couple of examples. Without the proper knowledge on the ground, you can come out with wrong interpretation. So that's definitely an aspect to account for.
I think the key to preventing that problem in the future, you're not going to hold back information. We live in an information world. There will be more and more information and more false interpretation of information. I think the key is transparency on the methodology, so that people understand which products have been validated, which products are done remotely with poor data. In this recent Haiti earthquake experience, the post-disaster needs assessment team initially received a report that was presented by a group of retired ministers who said that the report was based on satellite data and presented the exact damages. But when we looked into the report, it was actually based on data that was very old. They were comparing the situation with 2014 and then immediately after the earthquake, and were making many false conclusions from that data. And that became clear as soon as the methodology used to develop the product was exposed. And so I think if we have open systems with open data, it's very important to have the metadata and to have the methodology explained so that people understand, and then they develop, as Deodato said, a critical sense with regards to the data, and then I think the problem eventually goes away.
Alessandro, probably we do not hear you anymore.
Sorry. Yeah, that's sorry. We have a question for Diodato from Manuel. He's asking essentially if we observe an issue in the uptake of the data information by end user. He also say, of course, we develop services according to user needs, but the usage seems to be much limited than the original community showing interest. So do you think, what are the reason for this discrepancy? So a lot of people interested if you are using the data.
To be honest, during the DRO pilot, because the activity was co-designed with local stakeholders and users, the interest was very high, of course. So that's a model that we have experienced directly in the CEOS working group disaster. If you co-design directly the application with your user, basically you create an engagement process by which your users are interested. Of course, that's a specific type of model of working. Of course, there's also the development of services and platforms that are developed assuming that there's out there a broad arena of users. I believe that the way to attract them and keep their interest up is also making sure that in some way these services can be tailored to their own needs. For example, we experienced that with the geohazard exploitation platform, because of course the concept of the platform is to provide consolidated routines to process this data, but of course not all the routines are let's say tailoring at the same way all the potential application sides. And that's something that you can add in the post-processing phase of those products retrieved from those processing routines if you engage directly with the users, allowing them to express an interest, express a need, and let them see that their own needs are addressed in some way. Otherwise, they would perceive these tools, these platforms as a black box that cannot be adapted to their own cases. That's in my opinion and my experience why sometimes we have a divergence between the user community and the providers.
Thanks, Diodato. So I don't know if there are other questions from the panelists, from the attendees. And I think, yeah, we were expecting a much longer session, so there should have been a second part, but as I say, we had some defection, and I do apologize for this. In case there are no further questions, I would just say thanks to Andrew, Diodato, Manuel, and Lorenzo for their time, and of course also the attendee to find the time to be here today. And yeah, I think that's it. Hopefully it was useful and you enjoy it. And yeah, I just wish you a good day and a good weekend.
Thank you, Alessandro. And I want to reiterate the invitation to those participants that were not vocal today. I'm sure the presentations will be shared. You have our email contacts. If there's interest in participating in the RO demonstrator by providing some scientific products or more commercial products in response to major events, we're certainly takers. So look forward to hearing from some of you.
Thank you, Alessandro, for the invitation and the coordination of this interesting session. And it has been a very real pleasure, and thank you.
Thanks everyone. So
thank you so much, Alessandro, also, and all the audience. Thanks a lot.
Bye.
Bye.
Bye.